What's up, everyone? It's Jason again. In this series, I'm calling my Quick Hit Tech Tips, as I will be quickly going through individual Siemens function blocks. I'll be talking about their inputs, outputs, and how to use them. I hope you enjoy.
How's it going, everyone, and welcome back. Today, we're going to continue talking about our individual MC block available for Siemens technology objects. As always, these are ISO specified blocks, so other manufacturers may have the same name and the same functionality in their blocks. So you might be a little more familiar with these blocks than you realize. This block today we're going to be talking about MC MoveRelative. As you might guess, this block is going to make this axis move. In order to do that, you need to be familiar with MC Power, MC Reset, and at least MC Halt. An MC MoveRelative, the axis does not need to be homed since it is moving from wherever it is currently to a value relative to it. So it doesn't need to know absolutely where it is, but it's still good practice to home an axis. So if you aren't familiar with these blocks, please watch the other videos that I have on these blocks. Without any more delay, let's talk about the MC MoveRelative. As you can see, this is the first block that has a lot more inputs than we have seen so far. We still have the axis input, which, in order to populate, we can drag out of the project tree onto the block. We also still have the execute and some other familiar inputs. What this block is actually going to do is make the axis move the distance you input at the distance parameter. Now that value is in millimeters, inches, degrees, however you have your technology object configured, it's going to move that distance. So if you're wanting to move 2 rotations and your axis has a modulo of 360 degrees, then you want to put in 720 degrees. If you have this axis set up in a linear axis, you'll put it into some sort of length unit, say millimeters or inches. That's going to be that distance. This block will move that distance at a maximum velocity as inputted at the velocity input. It will accelerate and decelerate according to the inputs at the block. Finally, you may input a maximum jerk allowed at this input. If you don't set a maximum jerk, it will go to the default maximums. If you set this value to a -1, it will use the default values, both of which are configured in the technology object. Now, we've talked about all of the outputs before on other blocks: done, busy, command aborted, error, and error ID. As always, you can click on the block, click F1, and it will bring up the help files with explanations of all of these values. A word of advice that I will continue to say on all of these blocks is that the done output is only true for 1 cycle after the move is completed. If you are monitoring whether or not this axis is in motion, it may be better to monitor the busy bit instead of the done bit, and you would do that by putting a not busy in your logic. Finally, we've talked about command aborted. In a MoveRelative, this may be more valuable of a tool than in other motion control functions, because this motion may take several seconds to several minutes to complete. So if something interrupts it, you will want to know what actually interrupts it, and that will be signified by that command aborted. Now, that's fairly straightforward. Let me talk to you a few things that I have found about troubleshooting this block. First, if this velocity is 0 and you execute this move, the busy signal will go true and it will sit there forever because the velocity is only moved into the block once when you trigger the execute. If you go in and change the velocity after the fact on this MoveRelative, it still will not move. You have to re-trigger the execute. But there is a way to change the velocity in the middle of the move by changing what is called the override velocity. The override velocity is available in the positioning axis, and underneath the overrides, it is available as an L-real velocity. The reason you may want to do this is you may have a very long relative move that you want to change the speed of during the move. This can be done at any point by changing the override velocity. Warning, if you mess with the override velocity and you somehow set it to 0, even if you have a 100% value here in the velocity, it will not move because a 0 velocity override means 0% available speed. By default, this value is 100%. And so it is 100% of this value that you input here. Once again, note that these inputs, distance, velocity, acceleration, deceleration, and jerk, are all in your engineering units set up in technology objects. So velocity is never in RPM. It will be in degrees per second, millimeters per second, inches per second. Acceleration will always be in degrees per second squared, millimeters per second squared, inches per second squared. And jerk will always be in your engineering units such as degrees per second cubed or your linear units. The second thing that I would point out if your axis is not moving is make sure that your acceleration and deceleration are not set to 0. It will perform just the same as if you had your velocity set to 0. It will activate the block, the busy signal will go true, and it will sit there and do nothing. Because if you cannot accelerate, you cannot move the axis. I will make a note here though that the override velocity only overrides the velocity. It does not override the acceleration. While you may be only moving at 10% velocity, your acceleration and deceleration values will still be at 100%. This is a basic overview of the MoveRelative block. Again, a MoveRelative is wherever you are now, it will move a distance at a velocity and acceleration from wherever you are. In the next episode, we'll be talking about an MC MoveAbsolute, which sounds similar but has completely different functionality. Hopefully you'll come back for that one. If you found this video helpful, please hit the like button and subscribe for more videos. I hope to see you then.